Welcome to my YouTube channel, A Brainery of Civil. Today I am going to solve the last assignment of reinforced concrete road bridges. So this is the last assignment for this course. Actually RCRB is 1 month course, that is 4-week course. So you can solve all the problems. Most of the questions will be repeated in the NPTEL exam. Okay, shall we start? Okay, first question. As per Pigot's curve, the moment coefficients m1 along shorter direction is found as 0.140, whereas the moment coefficient m2 along longer direction is found as 0.040. Considering Poisson's ratio of concrete 0.20 and the total load 40,000 kilonewton, the bending moment along longer direction is equal to. So he has given some options. So he has given m1, that is moment coefficient along shorter direction as 0.140 and moment coefficient along longer direction 0.040, and he has given Poisson's ratio of concrete 0.20 and concentrated load P is equal to 40,000 kilonewton. Okay, so this is the information that he has given. We need to calculate moment. So moment computed along longer direction. So m is equal to m2 plus mu m1 into p. So this is the formula we need to remember. Along longer direction, so m2 and mu times shorter direction coefficient. So this entire thing multiplied with point load, that is a concentrated load, that is 0.040 plus 0.2 into 0.140 into 40,000. So I will get 2720 kilonewton meter. Clear? So for question number 1, the answer is 2720 kilonewton meter. Okay. Next question. A simply supported beam of span 22 meters is loaded with IRC class A loading. The front wheel of load P1 is equal to 27 kilonewton is at a distance 2 meters from the left support. The portion of remaining wheel loads with respect to previous wheel load and the corresponding load are. He has given load and the distance between previous wheel load and the present load. Okay, this you need to observe here very carefully. Okay, because we need to place the load according to the distances he has given. Clear? And the portion of the resultant load is, so question number 2, 3, 4, 5 are only related to the same data. Okay, don't be afraid of this. He has given so many loads and the distance between the loads. Okay, so it is very simple problem. Okay, now what he has given is, first of all, he has given a simply supported beam. This diagram is the most important one. If you can able to understand this diagram, it is very easy. The entire problem is very easy. So this is A and this is B. So the total span of the beam is 22 meters. Clear? And he has given load P1 kilonewton, that is 27 kilonewton, is at a distance 2 meters from the left support. This is left support A. So there is a load here. P1 is equal to 27 kilonewton. So this P1 27 kilonewton and the distance between this left support and P1 is 2 meters. So that is he has given in the information. Now with respect to this P1 is equal to 27 kilonewton, the second load has been placed and the third load has been placed with respect to second load. similarly and so on. So now according to the data he has given, I will arrange all the loads. Clear? So now this 1.1 meter and 27 kilonewton load. There is one more 27 kilonewton load. The distance between last load to present load is 1.1 and 114 kilonewton. This is 114 and the distance between last load to present load is 3.2 and again 114 kilonewton. The distance from last load to present load is 1.2. After that 68 kilonewton and the distance is 4.3. After that one more 68. The distance is 3. One more 68. The distance is 3. So this is 68, 68, 68 and one more 68 kilonewton. The distance is 3. Okay. So if you will take this entire distance, so 2 plus 1.1 plus 3.2 plus 1.2 plus 4.3 plus 3 plus 3 plus 3. So this entire you will get, it is 20.8. So this will be total span is 22 he has given in the problem and the remaining distance is 1.2 meter. So this is the arrangement of the load. Clear? This diagram you should able to understood. Clear? Now what he is asking, the position of the resultant of the load from the wheel load P1 will be. So now resultant load R will become summation of P values. So that is how much? 27 plus 114. Similarly you have two 114 loads and 68 into 4. So there are 468 kilonewton loads. So the total summation will be 554 kilonewton. So this will be 554 kilonewton. So this is the resultant. So now I am treating the resultant is somewhere at a distance x from this point, that is from first load. So let C is the first load point and this is resultant. I will take moment about point C is equal to 0. So this resultant will create anti-clockwise moment and remaining all the loads will create clockwise moment. This is clockwise, this is clockwise, this is clockwise, this is clockwise. Clear? Resultant will create anti-clockwise. So that resultant R into X is the moment about this point C is equal to 27 into, so this first 27 kilonewton will not create any moment about that point itself. So next remaining 27 will create moment about point C. 27 into 1.1 plus 114 into 4.3 plus again next 114 into 5.5 plus 68 into 9.8 plus 68 into 12.8 plus 68 into 15.8 plus 68 into 18.8. So these are all the distances. I'll explain here. 27 into 1.1, 114 into this perpendicular distance, 114 into this perpendicular distance. Like this you need to multiply, you need to take moment about point C. So by placing R is equal to 554 kilonewton, you will get X as 9.091 meters. Okay, so this X is equal to 9.091 meters. Clear? So the resultant lied at a distance 9.091 meters from left support or from first load? From first load. It is not from the left support. So the answer for this question is answer C. Clear? Now coming to next question. He has given same data until problem number 5. In this question, what is the question? The reaction at the right support is. So I'll copy the same diagram here. So it will be the same diagram. I am copying here. So now he asked right support reaction. This is RB and this is RA. I will take moment about RA, that is about point A. Sigma MA is equal to 0. RB will create anti-clockwise moment, remaining will all the loads will create clockwise moment. So RB and span is 22, that is equal to 27 into 2 plus 27 into 3.1 plus 114 into 6.3 plus 114 into 7.5 plus 68 into 11.8 plus 68 into 14.8 plus 68 into 17.8 plus 68 into 20.8. You will get RB as 279.295 kilonewton. So that is answer C for question number 3. Next question. He asked left support reaction. We know already RA plus RB is equal to summation of all the loads. Summation of all the loads is equal to 554. So to calculate RA, that is 554 minus RB. So RB. So what is RB? 554 minus 279.295. So you will get it is 274.705 kilonewton. Okay, so very simple. RA plus RB is equal to total all the loads. That sum we got, it is already R as 554. Clear? So for question number 4 it is answer D. Now question number 5. So same data. What he asked in this problem is the bending moment at the point load P2 is. So that is at the second load. So now I am copying the same diagram again. So you can see here. So what he is asking? He is asking this is P1, this will become P2. So at this point what is the bending moment? So I am taking about this point D. D is the second load point. So bending moment at D is equal to, so this RA will create clockwise. This is anti-clockwise. We can calculate bending either from the left or from the right. On the right of the point D there are so many loads. We will not consider that. On left, one reaction and one load. So this RA into, what is the distance? 2 plus 1.1. 2 plus 1.1 minus 27 into 1.1. So what is RA actually? 274.7045 into 3.1 minus 27 into 1.1. So that will be is equal to 821.884 kilonewton meter. So for question number 5, answer B. Okay, so if you will get this type of questions, it is very easy to solve. Okay, don't be afraid by staring at the diagram. It is very simple problem. According to the load he has given as P1, which is at a distance 2 meters from the left support. Remaining all the loads will be arranged based on that. Clear? Next, again question number 6. The carriageway of a bridge. So I'll write the data as given. So carriageway is equal to 7000 mm. So that is he has given. And footpath, width of footpath. So that is B is the width and FP is footpath. So 1200 mm. And is provided on one side of the bridge. The cross barriers having base width 450 mm is provided on both sides. That is, there are 2 cross barriers. One is on the left, another is on the right. So that is width of crash barriers. So that is B, crash barriers is CB, is equal to 450 mm. Okay, now he is asking center to center girder spacing will be. So we have a formula, girder spacing GSP, spacing is SP, G is girder. So we have a formula for this, BCP, that is width of crash barrier plus carriageway width plus width of footpath plus crash barrier, well, divided by crash barrier, here it is CP divided by 3. So that is 450 plus 7000 plus 1200 plus 450 divided by 3. You will have it is 3033.3 mm. Clear? So the answer is answer C for question number 6. Okay, very simple problem. You need to remember this type of formulas to solve this question. Without formula you cannot deal the question. Okay, next question, the carriageway. I'll write the data again. So carriageway is equal to 7000 mm he has given, and width of footpath is equal to 1200 mm, and provided on one side of the bridge. The crash barriers, that is width of crash barriers, that is BCP, is equal to 450 mm, that is it is provided on either side of the bridge. Considering 3 longitudinal girders of RCC bridge and length overhang on other side, half center to center. So again the girder spacing, we have formula for this question is GSP is equal to BCP plus CW plus BFP plus BCP, crash barrier, divided by 2 into 4. Okay, so depending upon the longitudinal reinforcement and the number of girders, we need to change the denominator. So you will get it is 450 plus 7000 plus 1200 plus 450 divided by 8. So you will get it is 1137.5 spacing mm. Okay, so 1138, so it is approximately 1138 mm. So for question number 7, answer B. Clear? Now coming to question number 8. So question number 8, 9, 10 are somewhat lengthy questions and there are few formulas. Be careful. So the overall depth of a deck slab of RCC T-beam bridge is 230 mm. So that is depth of his flange is equal to 230 mm he has given, and overall depth of T-beam is equal to, that is capital D, is equal to 1800 mm he has given. Thickness of the web at mid span is equal to 325, that is web width is equal to 325 mm, and flange width at RCC is taken as 2200, that is width of the flange is equal to 2200 mm, and center to center, that is a clear cover, is equal to 30 mm, and diameter of the bars that he is using here is 32 mm. Along with this data, he has given M35 and FE415. He has given KUB. So that KUB is equal to 0.48. You need to remember these two values to solve this question. So it is lambda C is equal to 0.80. Clear? So here KUB is equal to neutral axis factor. Okay, so neutral axis factor is for FE415 it is, so I'll write some values here, 0.53, 0.48, 0.46. This is neutral axis factor, this is for FE415, this is for FE250, this is for FE500. Okay, so you just remember this only value because he is giving only 415 steel. Clear? And this is stress reduction factor. So for FE415 the stress reduction factor is 0.80. So now what he is asking the ultimate moment capacity of concrete is. So now we'll solve this problem. Moment of resistance due to web. So that is MU because of W, that is web. Okay, is equal to 0.45 FCK and D suffix C KUB 1 minus 0.5 KUB into lambda C BW into D. Clear? So substitute the values. 0.45, FCK he has given 35, and this is lambda C, stress reduction factor lambda C is 0.8, KUB is 0.48 into 1 minus 0.5 into 0.8 into 0.48 into, and BW it is 320 given and 1754. If you want to get this entire moment capacity in kilonewton meter, just multiply it with 10 power minus 6. That is, all the units are in Newton mm. So to convert this Newton mm into kilonewton meter, multiply 10 power minus 6. So you will get it is 4879.21 kilonewton meter. Clear? So this is moment of resistance due to web. Now, moment of resistance due to flange. So we will have one more formula. MCF is equal to 0.45 FCK BF minus BW into DF, D minus 0.5 DF. Okay, so these are all the derived formulas, so you need to remember. So now 0.45 into FCK is 35 into 2200 minus 325 into 230 into 1754 minus 0.5 into 230. So into 10 power minus 6. So you will get it is 11132.40. So now moment of resistance due to concrete. So due to concrete is moment of resistance of web and moment of resistance of flange. So you just start both the values. So 487.9 plus 1132.40. You will get it is 16011.60 kilonewton meter. Clear? So the answer is 16011.602 kilonewton meter. This is the total moment capacity of concrete. So this total moment capacity of concrete can be computed once is summation of moment of resistance because of the web, moment of resistance because of the flange. These two summations will give you total moment of resistance of concrete section. Clear? So the answer for question number 8 is C. So now coming to the question number 9. So he has given same data. I won't read much. But what he is asking, tensile reinforcement in the balanced section is computed as. Okay. So first I'll write the given data. So that is DF is equal to 230 mm and D is equal to 1800 mm and BW is equal to 325 mm and BF is equal to 2200 mm and KUB, that is neutral axis factor, and lambda C, stress reduction factor. So it is KUB is equal to 0.48, stress reduction factor is 0.8. Along with this, clear cover 30 mm, diameter of the bar he is using is 32 and M 35 and FE 415 steel. So this entire data he has given. Okay. So now you can see compressive force due to web. First I will calculate compressive force due to web. So that is equal to 0.45 FCK lambda C KUB into BW into D. So that is 0.45, 35, 0.8, 0.48, BW is 325 and D is equal to 1754. So okay, so into 10 power minus 6. Okay, you get it is 3441.25. It is not 10 power minus 6, it is 10 power minus 3. Here we are not calculating moment of resistance, we are calculating it is a force. So to convert the newtons into kilonewton, we need to multiply it is with 10 power minus 3. Okay, so this is compressive force on the web. Now compressive force due to flange. So we have one more formula, 0.45 FCK BF minus BW into DF. So that is equal to 0.45, FCK is 35, 2200 minus 325 into DF is 230 into 10 power minus 3. you will get it is 6792.19 kilonewton. So now compressive force due to concrete means it is summation of web as well as flange. Compressive force due to concrete is equal to, earlier we got it is 3441.25, 3441.25 and it is 6792.19. So total force it will be 10233.44 kilonewton. This is entire compressive force CUB. Okay. So now this entire compressive force has to be resisted with tensile force. As the section he has given is, it is a balanced one. So now area of steel in balanced section, AST bal is equal to CUB divided by 0.87 Fy. So what is CUB? 10233.44 into, so I will convert this into newtons. 0.87 Fy is 415. You will get it is 28343.55 mm square. Clear? So the answer for this question is answer A for question number 9. Okay. So and last question. So I'll write the same data what he is asking, but what lever arm factor parameter is. So what is the lever arm factor parameter? So he has given DF is equal to 230 mm and D is equal to 1800 mm and BW is equal to 325 mm and BF is equal to 2200 mm and clear cover is equal to 30 mm and dia is equal to 32 mm and it is M35 and FE415 and stress reduction factor lambda C is 0.8, neutral axis factor KUB is equal to 0.48 and so this effective depth is equal to overall depth minus CC minus pi by 2. This you already know in the last assignments. 30 minus 32 by 2, you will get it is 1754. So lever arm design moment he has given as MU is equal to 12,000 kilonewton meter and K web, that is lever arm factor web, is equal to MU minus MUCF divided by 0.9 FCK BW D square. Very important formula. So 12,000 minus 1132 point. So this 1132 point we have calculated in problem number 8, that is moment of resistance due to flange. So we got it. So this is moment of resistance of flange. Okay, so in the 8th problem we got this MUCF 32.395. I am converting this into Newton meter. This is 10 power 6 and 0.9 FCK is 35, B is equal to 325, D is equal to 1754. So it is BD square. So you will get it is 0.028 is the answer. This is the lever arm factor 0.028. Okay, so this is the end of the assignment 4 and this is the end of reinforced concrete road bridges. Clear? So I hope those who are watching my videos, all the 4 assignments, so if you want you can revise all the videos once again. So if you have any doubt, post your doubts in the comment section. I will try to clear all the doubts. Okay, so I hope you will get the best percentage in NPTEL certification in reinforced concrete design courses. Thank you.